partition function. It is the function of the thermodynamic state variables. So it is used to find the thermodynamic parameters. There are three types. The most common are canonical, grand canonical partition function. So canonical is nothing but the system for which the temperature is constant and the energy varies. In grand canonical, it is applied for the system for which temperature and chemical potential is constant and energy and number of particles varies. The expression for canonical partition function is Q equal to summation of e power of minus e by kt, and the relation relating the canonical partition function and thermodynamic quantity Helmholtz free energy A is given. A equal to minus kt ln of Q. From this relation we can find thermodynamic quantity using partition function. And grand canonical partition function and thermodynamic quantity is related as P equal to kt ln of Q. This is a problem related to partition function. A system has two normal modes of vibration with frequency omega 1 and omega 2. What is the probability that at temperature T the system has energy less than 4 h cross omega? So the answer is given. So here x is e power of minus beta h cross omega and z is the partition function of the system. So what is the energy of a vibrator? E equal to n plus half h cross omega. Since there are two possible modes of vibration, E equal to n1 plus half h cross omega and plus n2 plus half h cross omega 2. So what we have to calculate is, we have to calculate the energy for different values of n1 and n2 for which the energy does not exceed 4 h cross omega. That is the given 4 h cross omega. It should be less than 4 h cross omega. The energy value calculated for different values of n1 and n2. When n1 and n2 are 0, we are getting 3 by 2 h cross omega. And for n1 equal to 1 and n2 equal to 0, 5 by 2, and n1 equal to 0, n2 equal to 1, 7 by 2. And again for n1 equal to 2 and n2 equal to 0, we are getting again 7 by 2. So therefore 7 by 2 h cross omega is doubly degenerate. And when n1 equal to 1 and n2 equal to 1, we are getting 9 by 2, which is greater than 4. So there are 4 possible energy states which is less than 4 h omega. Substituting these values in probability expression, probability is nothing but summation of the energy e power of minus e by kt. So there are 4 possible energy: minus 3 by 2, minus 5 by 2, and minus 7 by 2. 2 W degenerate minus 7 by 2. So we are adding in the numerator. In denominator we are dividing by the partition function. Partition function is nothing but summation of all the possible states, that is the integration of e power of minus e by kt. So here instead of e power of minus beta h cross omega, we are substituting x and we are getting the answer as x 3 by 2 whole bracket 1 plus x plus 2 x square by z.